Hello everyone. In the previous class, we have seen the definition of combinational and sequential circuits. And in sequential circuit, as I told you before, the memory elements which we are using are flip-flop. So the basic flip-flop which we will be studying here is in this presentation is SR flip-flop. So here we will be studying about SR flip-flop. So S stands for set, R stands for reset. So I'll write the logical circuit for SR flip-flop using NAND gates. Usually we use NAND gates. Yes, this is the logical circuit for SR flip-flop. So SR flip-flop consists of two inputs, that is S and R, and two output, that is Q and Q bar. So always Q and Q bar are complement to each other. And one more input we are using, that is nothing but the clock signal. So clock signal is very important to activate the SR flip-flop. That means the output changes whenever there is a change in the clock signals. Whether this clock may be either positive triggered or negative triggered. So depending upon the type of triggering, the output changes whenever the clock is triggered or whenever the clock is changed. Okay. So since before analyzing the circuit, since we are using the NAND gate, let me write first the truth table of NAND gates. So let me take the input of NAND gate is A and B, 0, 0, 0, 1, 1, 0, 1, 1. I'm having two inputs, so I'll be having four combination of input. So NAND is nothing but negation of AND. So NAND is nothing but negation of AND. So the output of AND is high only when both the inputs are high. In all other cases, the output is low for AND gate. So it is negation of AND. So output will be reverse of AND gate. So AND gate output is high only for 1-1 combination. So here I'll write 0, 1, 1. So this is NAND gate. So after knowing the truth table of NAND gate, let me realize this SR flip-flop. So first, let me take the first condition. So here I will be writing the output, that is truth table for SR latch. SR input, Q and Q bar is the output. Okay. So first, I'll take this condition later. Let me take the first condition, S is equal to 0 and R is equal to 1. So here I am taking S is equal to 0, R is equal to 1. Let me assume the circuit is activated. That means I'm giving the clock pulse. So 0 and 1. Here clock is equal to 1 and 1. See the NAND gates, whenever the inputs are 0 and 1 in the NAND gate. So here SR flip-flop, I'll be having 4 combination 0, 0, 0, 1, 1, 0, 1, 1. So presently I am taking this condition when S is equal to 0, R is equal to 1 and the clock is high. Clock is high in all the cases. So for the NAND gate, when S is equal to 0, R 0 and 1, what is the combination of output? 1. For 1 and 1, the combination is 0. So this is 1 and this is 0. See, I cannot predict the output of upper NAND gate because I wanted to know if 1 and 0, then I will get the output as 1. If it is 1 and 1, I'll get the output 0. But I can take the output of this. So if any of the input is 0, the output of Q bar is 1. See here, if any of the input is 0, output is high. So output of Q bar is 1. This 1 will go here. So 1 and 1, output is 0. Q bar is 1. So when S is equal to 0, first case 1, when S is equal to 0, R is equal to 1, what is the output I am getting? I am getting Q is equal to 0 and Q bar is equal to 1. So Q is equal to 0 and Q bar is equal to, sorry, here when Q is equal to 0, Q bar is equal to 1. Okay. Next second case, I'll take other condition. So second condition, I'll take S is equal to 1 and R is equal to 0. S is equal to 1 and R is equal to 0. When S is equal to 1, I'll rub off the previous values. Yes. When S is equal to 1, second case, when S is equal to 1, R is equal to 0. When S is equal to 1, R is equal to 0. So here it is 1, 1. When 1 and 1 are given to NAND gate, output is 0. When 1 and 0 is given to NAND gate, output is high. So I cannot predict the output of lower NAND gate. So upper NAND gate, this is 0. Whenever one of the input for the NAND gate is 0, the output is high. So this high is given as an input for other NAND gate 1 and 1. For a NAND gate, if you are giving 1 and 1 as input, your output is 0. So Q bar is equal to 0, Q is equal to 1. So for SR flip-flop, whenever you are giving the condition S is equal to 1 and R is equal to 0, the output is Q is equal to 1, Q bar is equal to 0. Here it is 0 and 1. And change this. Okay. Now I'll come for first condition. So first condition is when both are 0, 0. I'll drop the previous values. When S is equal to 0, R is equal to 0. So clock is high. When S is equal to 0, R is equal to 0. Here clock is high, 0 and 1, the output is high. 1 and 0 also, the output is high. So let me take the previous, I cannot predict the output of both the flip-flop, because if I'm giving 1 and 1, the output is 0. If I'm giving 1 and 0, the output is 1. So let me take the previous output of Q was, since we have done this condition, Q was 1 in our previous case, Q was 1 and Q bar was 0. This was the previous output. Keep it in mind, this is the previous output. So if the previous output was given this as an input to this and Q bar is equal to 0, then 1 and 0, this is 1 and 1 and 1, the output is 0. This is previous and this is the current output. That is whatever the output I'm getting, 1 is 1 and 0. Please check it. The present output and the previous output are same. That means if I'm giving both as 0, 0 as input for S and R inputs of SR flip-flop, the output will not change. If Q was 1, you will get Q as 1. If Q was 0, you can check the other condition also. If I am taking previous output as 0 and 1, you will get 0 and 1 only. So this state you call it as memory, or sometimes you call it as no change. That means there will not be change in the output of the flip-flop if you are giving both the inputs as 0 and 0. Clear? Next condition, the only condition which is left out is 1 and 1. Let me erase the previous conditions. Yes. Let me take the condition 1 and 1. So when S and 1 R is clock is equal to 1, output of this NAND gate is 0. 1 and 1, output of NAND gate is 0. So irrespective of other input, if one of the input to the NAND gate is 0, your output will be high. See, Q is also high and Q bar is also high. This is a contradiction. That means you cannot have Q and Q bar as equal. Always Q should be complement to Q bar. So what is the meaning of this is, we cannot make use of these combination of inputs in case of SR flip-flop. If S is equal to 1 and R is equal to 1, this condition we call it as invalid condition. That means we cannot make use of these combination of inputs in SR flip-flop. I can have S and R as 0, 0, 0, 1, 1, 0 and 1, 1. I hope you understand this. Thank you.